coming down.
All right.
And the meteors are actually fire-emitting particles, so they actually have a couple effects in the system. So here we got our meteors. And if I swing around and look at the house, so we've actually got a bunch of trees. These are procedurally generated trees. We've got some procedural fire that's coming down, and we go a little further. So we've actually got these meteors, and they're actually emitting flaming particles. And so there's the visual particles that you can see, and there's these actual virtual particles which are actually all in the CPU right now. So I've got the simulation turned off. So the procedural fire is actually 1%. But a couple things are going to happen. So we actually have real physics going on. So this house is made up of about 5,000 different pieces. When the meteors interact with it, you're going to see the house get destroyed. The meteors are actually going to fracture. You'll see bits of meteor come off. You'll see them flaming. And as the flaming bits go near the trees, they're emitting these virtual particles. And as the virtual particle hits another thing that can catch fire, which is either a house or a tree, it will actually set that on fire, and then that will start a whole series of particle emitters, like, for example, going up the branch of the tree. So you actually see a tree catch fire, and the fire will spread across it. And it's all done dynamically. So you can see the house get smashed, the trees catch fire. So we're actually running a physics simulation. We're doing a procedural fire simulation, and you can see the fires are supposed to be spreading across all the trees. So we've got it turned up a little bit so the trees actually catch fire pretty quickly to show what's going on. You can see the trees catching fire down there. So what we've got is between 50 and 60,000 particles, particle simulations all running in the background, and the end result is the fire on here. So there's this huge amount of CPU load that's going on. You can see we're running on a Nehalem system, which is a 4-core 8-thread system. So we're actually spreading the procedural fire and everything else across all 8 threads, doing a simulation, and then at the end of each render frame, we're taking the result of that simulation and actually presenting it in the graphics system. So we're doing a lot of very complex simulation, taking the results of that and then just sticking in as a bit of graphics highlight on there. So we're actually trying to create a very rich visual environment from a lot of work that's done behind the scenes on the CPU. So if you have a multi-core system, think something like this will scale.